practice writing ionic formulas. To complete this exercise, you will need your periodic table. Let's start with a compound composed of barium and chlorine. If you look at your periodic table, you will see that barium is located in group 2. Therefore, barium has a charge of +2. Chlorine is located in group 7. Therefore, the chlorine ion has a charge of -1. You will recall from the lecture that all elements in group 1 typically have a charge of +1. All elements in group 2 have a charge of +2. All elements in group 3A have a charge of +3. Elements in group 5A typically have a charge of -3. 6A have a charge of -2, and 7A have a charge of -1. If you do not recall this or are still confused, please refer to that lecture. So, barium has a charge of +2 and chlorine has a charge of -1. You will remember that the total positive charges must equal the total negative charges. The compound must be electrically neutral. Barium has a charge of +2. Therefore, each barium ion has 2 pluses. Chlorine has a charge of -1, therefore each chlorine has a charge of -1. If you were to combine the two in a 1-to-1 ratio, you would have one of the positives canceling the negative of the chlorine. However, that would mean you would have a leftover charge of +1. Adding a second chlorine would give you a second negative charge. Therefore, the positives and negatives cancel each other out. And the formula for this compound must be BaCl. There are 2 of them. BaCl2. Let's try another one. Let's try sodium and oxygen. Sodium falls in group 1. Therefore, sodium ion has a charge of +1. Oxygen, looking at the periodic table, falls in group 6A. Therefore, oxygen has a charge of -2. So if we write the charges underneath, for sodium we get 1 positive, for oxygen we get 2 negatives. If you were to combine these in a 1-to-1 ratio, the positive on the sodium would cancel one of the negatives on the oxygen, leaving us with 1 negative left over. Therefore, to balance this, we have to add a second sodium, also with a charge of +1. Okay. Then, the positive charge on the sodium cancels the second negative on the oxygen. Therefore, the formula for this is Na2, 1, 2, Na2O. Let's try another one. Let's try a mixture of aluminum and chlorine. Aluminum is a metal. It is found in group 3A. Okay? It has a charge of +3. Chlorine, as we said previously, falls in group 7, therefore 7A. Therefore, chlorine has a charge of -1. So, 1 aluminum has 3 pluses. 1 chlorine has 1 minus. If you were to combine these in a 1-to-1 ratio, the positive charge on the aluminum cancels the negative on the chlorine, leaving us with an overall of +2. Since they must be electrically neutral, we must add at least 1 more chlorine. So let's add another one. Okay. Now, 2 of the positives have canceled, but we still have 1 left over. Therefore, we must add at least 1 more chlorine with a negative charge. Now, all 3 of the charges have canceled, giving us a formula of Al. Oops, wrote that in green, didn't mean to. Let's erase that real quick. Black. Al, there is 1 of them. Cl, there are 1, 2, 3. Cl3. Okay. Aluminum and chlorine. All right, let's try one more. magnesium, and nitrogen. Magnesium falls in group 2A, so its charge is +2. Nitrogen falls in 5A, its charge is -3. If we write the charges underneath, we get plus, plus. If we write the charges underneath the nitrogen, we get minus, minus, minus. In a 1-to-1 ratio, one positive cancels one negative, second positive cancels second negative, we have one negative left over. Of course, we know they have to be balanced, right? So let's add a second magnesium. Now, magnesium is a +2, so if we add a second magnesium, we have to add 2 positive charges. Now, one of those positives cancels one of the negative. Now we have a positive left over. What do? Well, clearly we must add another nitrogen, which is a -3. Minus, minus, minus. Now, positive cancels negative. We have 2 minuses left over. What are we going to do? Have to add another magnesium. Magnesium +2. Ready? Plus, plus. Now, at long last, we are all even. So the formula for this compound is magnesium, 1, 2, 3, Mg3, nitrogen, 1, 2, N2. Now you might notice something about this. If we flip back to the initial problem that we tried, barium and chlorine. You notice the formula for this is Ba1Cl2. Notice the charges on the top. We have a 1 and a 2. So we took the 1 and we used that as our subscript for the barium and the 2 as our subscript for the chlorine. Look at the next one, NaO2. The sodium had a +1. Oxygen had a -2. We put the 2 on the sodium, the 1 on the oxygen. Aluminum had a +3 and a -1. If you put the 1 on the aluminum and the 3 on the chlorine, you get the same effect without having to go through canceling all the charges. This is particularly useful in a situation like this, where you must either use the least common denominators, right, to figure out how to get there with the charges, right? In this case, we had 6, so we had to multiply +2 by -3, and we had to multiply -3 by +2, or we drew the charges out, or you could simply take the 3 from the nitrogen, place it on the magnesium, and the 2 from the magnesium on the nitrogen. Makes life much easier, yes? If you have any questions about this or unsure where these charges are coming from, please refer to the previous lecture.